Hi, it's Mr. Springer, and I previously did a video on a demonstration where I mixed citric acid and sodium bicarbonate, the solid versions of each of those, in a flask with a syringe of about 50 milliliters of water, and we made some gas out of that. It fizzed quite a bit. It got a little bit cold, and I had thrown some universal indicator in to see what was actually going on. And we had a pretty good reaction go out of that. So what I thought I'd do today is show you how to balance an equation, complete and balance the equation for what we actually saw in the lab that day. So without any further ado, here we go. The sodium bicarbonate, or baking soda as it's commonly known, is a ionic compound. It includes a polyatomic ion, the bicarbonate ion or the hydrogen carbonate ion. Either one works. And the citric acid, um, it's also an ionic compound, and it's got the citrate ion along with the ionizable hydrogens is what makes it an acid. So I'd like to treat this as if it were a double replacement reaction, because that's pretty much what it is. It will vary slightly at the end. But as you remember on double replacement reactions, you put the positive ion from the first compound with the anion from the second compound, and we make sure that the charges are all balanced. And we do the same thing with the other. We take the positive ion from the second, add it to the anion from the first. So you may have memorized or have seen this bicarbonate or hydrogen carbonate ion on a list of polyatomic ions. Maybe you're memorizing those. Maybe you just have them at your disposal to use when you're doing lab or doing homework. You might not see the citrate ion on such a list, but we can figure out the charge of the citrate ion by looking at the positive, the cation that's with it. There are 3 hydrogen ions attached to that citrate, and each hydrogen ion we know carries a charge of +1. So if it takes 3 of them, then the citrate must have a charge of -3. So when I combine the sodium with the citrate, I'm going to need 3 of those sodium ions because they have a +1 charge in a 3C6H5O7. There's my sodium citrate. Now, that's not a gas. And we know we made a gas as a result in this lab. So we got to figure out what the gas might be. If I complete this as a double replacement reaction, I'm going to combine the hydrogens from the citric acid with the bicarbonate over here. And what we'll make when we combine those two, H and HCO3, we can make what's called carbonic acid, which has this formula. But the carbonic acid is known to break down or decompose into a couple things. We can make water out of that, and we can make carbon dioxide gas. So that's probably what's happening here, and the gas that we formed is the carbon dioxide. So we're going to make some liquid water and some carbon dioxide gas. So that completes the reaction. See if I can get that where I can balance it. There we go. So now we need to balance this equation. I'm going to go ahead and put parentheses around my citrate ion because it does not change from one side to the other. And so I find it easier to balance things with complex ions like that. Well, that's not a complex ion, but bulky ions as the same on both sides. So I've got a sodium over here. I've got a hydrogen over here. I've got a carbon and an oxygen. And I've got a citrate ion. That takes care of those 3. Even though we've got the hydrogen, the carbon, and the oxygen listed here separately, I can still keep that citrate ion together, and that saves me an awful lot of wear and tear. And I'll put list the same order on the other side for my atom inventory. I've got 1 of those. I've got 1 plus 3 would be 4 hydrogens. I've got 1 carbon. I've got 3 oxygens. Now remember, I'm keeping all these out of this part, and I'm just calling that 1 citrate. And on this side, I've got 3 sodiums, a citrate, 2 hydrogens, 1 carbon, 3 oxygens. So we're getting pretty close to being balanced. Well, we've got 3 of the 5 things are balanced anyway. Seems like a good place to start might be on the sodium ion, or the sodium, because I got 1 over here, I got 3 over here. It's only in one place. I'm going to throw a 3 right there. And by putting that 3, that changes this sodium to a 3. That makes my hydrogen now 3 plus 3 more, for a total of 6. The carbons, there are 3. And oxygen, I've got 3 times 3 will be 9. Well, that kind of messed up things on the other side, didn't it? Well, we can probably figure that out without too much trouble. Let's see, if I put a, let's go with the, I can do the hydrogen next. 6 of those over here, 2. So I'm probably going to need a 3 there, making that a 6, making that, oh, that's still a 1. We got 3 and 2 more would be 5 on the O's. Don't panic, we're still going fine. The carbons, I need 3, so I'm going to throw a 3 right there. 3 of those. Now I've got 6 and 3 is 9. And look at that, everything is balanced. So that worked out pretty well for us. In the next video, I'll go in depth into how much of these products we were able to make, and do a little stoichiometry to go with that. So thanks for watching.